Hey everyone, George Christie here with Wine Industry Network. Welcome to another episode in our Growing Forward series. Growing Forward is a webinar series that we put on, really targeting our grower audience. And today's session, which I think is one of our best ones, it's titled Grapevine Disease Detection and Prevention. We've got a great panel. Conversation is going to be led by Kris Lowe. She's joined by Marc Fuchs, Sarah MacDonald, and James Stamp. So perfect combination of researchers and consultants sharing their expertise with you today. So a couple things before we get started. First, I want to thank Verdi for their sponsorship. They're our presenting sponsor. And if you're not familiar with Verdi, you should definitely familiarize yourself with them. They're doing some terrific things from a technology perspective around irrigation, fertigation, really, really good stuff. So definitely check out Verdi if you haven't already. And the last thing before we get started is just to remind everybody that we always pre-record these a couple of days in advance. We do that for quality purposes. But we also do it so that we don't need to wait till the end of the presentation for Q&A. So our speakers are watching the broadcast right along with you. They're going to be monitoring the chat room. So as questions come to you while you're watching the presentation, go ahead and fire those off, and our speakers will pick those off as they come in. So yeah, we want to encourage you to do that. We want our sessions to be as interactive as possible. And we know how busy everybody is. All right, I think that about covers it. Once again, I want to thank Verdi for their sponsorship. I want to thank our panel, and I want to thank all of you for taking some time to be with us today. I'm going to hand it off now to Kris Lowe. Kris is going to lead today's conversation. Take it away, Kris.
Hi, everyone. My name is Roman Kozak, CTO and founder of Verdi. We make it easy to implement and manage a variable rate strategy for your vineyard. Our technology can break up your existing irrigation zones into as many subzones as is needed to match the variability of your field, whether that's based on soil type, terrain, or interplanting. Then we can direct more water to the areas that need it and restrict water to the areas that don't need it as much. So if you have vineyard blocks that look like the one above, we can help you make them look like the one below. And there are a lot of benefits to doing this, such as increased revenue per acre due to quality improvements, a restriction in water usage, as well as a single harvest pass. Verdi also engineers the most affordable irrigation automation solution for vineyards. The Verdi block controller installs in minutes and brings your existing valves, pumps, and sensors online for automation, monitoring, remote control, and alerts. Everything is simple to use from your desktop or your mobile phone. So if you would like to learn more, we would love to chat, so please reach out and we'll see you in the field soon.
Okay, well, thank you, George, so much for that introduction. And hello, everybody. I'm happy to have the opportunity to chat today about a subject that I'm really passionate about, and that's grape research on viruses. So I'm Kris Lowe, an independent vineyard consultant based in the North Coast. My business is Vine Balance Consulting, and I've also been the research coordinator for the Pierce's Disease Glassy Wing Sharpshooter Board for about 3 years now. And one of the reasons I threw my hat in the ring for that consulting position is because I came from a research background, and I find research really important. I think it's essential to our industry. And also, when I first started studying viticulture, and even when I finally entered the industry, folks were still talking about the incredible damage that phylloxera did, first in Europe and also here in California. But in my time in the industry and in my experience, it is viruses that give me the biggest headache and that I struggle with alongside my clients, trying to just plant and maintain healthy virus-free vineyards. So I'm really happy that our focus today is discussing grapevine viruses and red blotch in particular. And first, I just wanted to share a few comments about the Pierce's Disease Glassy Wing Sharpshooter Board and highlight our mission to fund important research for the California wine industry as it relates to combating these and other challenges. So this is where and why we started back in the late 90s. So in response to destruction in Temecula, the California wine grape growers passed the Ph.D. referendum, and that established an annual value-based assessment on wine grapes that funds research and related activities for designated pests and diseases. So established along with this referendum was the Ph.D. Board. And that's a unique joint wine grape grower and government-funded board, and it advises the CDFA on the use of Pierce's disease in glassy wing sharpshooter assessment funds. So the mission of the board, and also of my work as research coordinator, is to ensure that industry dollars are really spent wisely and productively to find solutions to our pest and disease issues. So while the original focus of the board was on Pierce's disease, and no one is taking their eye off the ball on that problem, the board has adapted over the years, expanding its research program to include work on other pests and diseases shown here. So today, our request for proposals covers all of these, current and even future here with the spotted lanternfly, serious problems for the industry. The current assessment rate is set at $1.25, and historically the average has been $1.35. We're a bit lower than that for the most recent 2023 harvest, and that's per $1,000 of crop value. And the assessment on crushed grapes is collected by the Ag Statistics Office, which keeps all the proprietary price and harvest information confidential and current. And this money is from and for the industry, funding research projects and outreach efforts related to Pierce's disease, glassy wing sharpshooter, and all the other board-designated pests and diseases, including viruses. There's been just over 83 million collected over the past 22 years, and that funds all of the research, including other activities like rapid response treatments for high glassy wing sharpshooter pressure nurseries, and also urban treatments. So some of you might have heard about the glassy wing sharpshooter eradication project in Vacaville, which is way too close for my comfort zone here in Napa, where I work mostly. So since 2001, the board's allocated about $55 million to research, the largest portion of which has gone to Pierce's disease and the glassy wing sharpshooter, but we've also allocated these funds to other pests and diseases and things like field trials, insecticide studies, economic analysis, and tissue culture and transformation work. As of last year, so much more recent look here at our distribution, our research portfolio includes about 45 different projects, and it's pretty evenly distributed between Pierce's disease and glassy wing sharpshooter, and work on viruses and all of their vectors. Also, some cutting-edge science on gene editing that we hope will open up even more options for sustainable, durable pest and disease control in the future. So our funding process is really critical, and that's important, and it's thorough. And it involves reviews by a scientific committee, as well as a more industry-based research screening committee. And then these recommendations are brought to the board, and then finally, ultimately, to the Secretary of Agriculture for funding. So really critical and thorough process to make sure assessment funds are spent well. And last year, very exciting, we started a project in collaboration with the National Academy of Sciences. And that's to get a real high level of expertise from scientists across the country on how our research funding program can improve and expand to combat grapevine viruses specifically. So there's a lot of activity going on right now on that project, and I'd like to take a few moments to tell you about that. So here's the project website, and I encourage you all to check it out and follow along on its progress. The project has three main tasks. So we started having the National Academy of Sciences committee members review separately from us the proposals submitted to the board in 2023. So they could get a chance to see what sort of proposals we receive about virus research and specifically, and we could kind of compare their thoughts on the proposals to the ones from our own separate scientific and research screening committees. And there was really good alignment there. Second, we have had the committee review our RFP and proposal selection process, and that resulted in some tweaks to the RFP for this year and some increased clarity on how we reach out to the scientific community to ask for proposals and then how they're evaluated. And then finally, the main crux of the work is going on right now. And this is where the committee is reviewing the current scientific knowledge of grapevine red blotch and leaf roll type 3 viruses, as well as their vectors, to help identify important knowledge gaps and direct our future research approach. So this third task has involved things like online public webinars, where the National Academy of Sciences Committee has had the opportunity to hear from the researchers who are active in studying these issues. There have been fantastic, comprehensive presentations on all things mealybugs by Dr. Kent Dane at Berkeley, as well as an overview of grapevine red blotch and leaf roll viruses from Dr. Fuchs, who's joining us today. And the interaction with the National Academy of Sciences Committee has become more dynamic as well, with meetings in person on March 5th and March 4th at Foundation Plant Services in Davis. And those meetings include a number of industry stakeholders, the Ph.D. board, and the members of the National Academy of Sciences Committee. So this is all part of the information gathering aspect of the project. And if you're interested, details on all of these events can be found on the project website, as well as the reports derived from each task of the project. So keep an eye out for the final report. It should come out by the end of the year, and all of this information is made publicly available. So now I wanted to take just a few more moments to highlight the breadth of our current research portfolio on grapevine viruses. So you get to hear directly from Marc today about his research experience with red blotch, which has really spanned the entire history of the industry's struggle with that virus. We're also going to hear from Sarah MacDonald, who's been instrumental in Monica Cooper's work that aims to bring current research into practice through extension. And shown here are all the titles of our other research projects on grapevine viruses and their vectors. So there is a lot of important work still to be done on grapevine viruses, obviously. But what we have represented here spans many different aspects of studying these pathogens. We've got work on understanding more about virus spread and identifying possibilities to disrupt or slow that spread, as well as early identification work, such as the project here by Luca Briante. He's trying to advance our skills at detecting virus in the vineyard even before symptoms are expressed, using hyperspectral imaging and machine learning techniques. And we have work on developing potential host plant resistance that would be incredibly valuable. And some of these projects are using cutting-edge biotechnology to do this, such as work again by Dr. Fuchs and also by Dr. Kuo at UC Davis. And of course, research is still ongoing to understand the exact mechanisms by which viruses impact wine quality, such as the work currently done by Dr. Oberholster. So you can find all of this information and more on the board's website, shown here, including things like research reports, symposia proceedings, our most recent At a Glance publication from 2023, and some great short videos created by our funding researchers about their work. So please check this all out. And with that, I'd like to pass the topic on to our other panelists. And I think first we're going to hear from Sarah on her experiences in researching red blotch.
My name is Sarah MacDonald. I'm part of Dr. Monica Cooper's lab at UC Cooperative Extension, Napa County, and I'm here representing our group. At UC Cooperative Extension, as Kris mentioned, we help bring current research into practice, and we help bring practical tools into the growers' hands to help them effectively manage these viruses. And so part of our work is about, with red blotch, is identifying symptom development and putting tools in growers' hands so that they're confident in identifying the disease in the vineyard. As we know, secondary red blotch spread is an increasing problem throughout our vineyards here. And we've been documenting this in several vineyards throughout Napa County over many years. And we've been showing how varying symptom development is essential to effectively managing the disease. So we have tools on our website. One of the tools we have is a Red Blotch symptom quiz, because one of the things we've noticed about this virus is it's particularly tricky to identify in the field. Often there are no symptoms, or only one cane or one leaf can show symptoms. So having confidence in your symptom identification is really key. Another tool we've been collaborating on developing is an AI-based app for your mobile device called Virus Vision. We collaborated with Thule Technologies to supply thousands of lab-verified infected vines into an AI-based app. And the model scans a vine within 10 to 20 seconds and will come back with a confidence reading in one of 4 categories. That's red blotch, leaf roll, other red leaf, or healthy non-infected vine. And so this is a really effective tool for scouting and education to give growers confidence in their red blotch assessments. It's not a definitive tool or identification, but it does at least help with scouting. And then we do have resources to then go back and test those vines with our in-house lamp assay. And we have resources for that on our website.
Well, thank you, Sarah. I'm definitely going to have some questions about some of the tools that you presented there. It looks like you're really taking the research and getting it out in growers' hands, which is the most important part, to be honest. So thank you for that information. And now I'd like to pass it on to Marc. Dr. Fuchs, go ahead.
Thank you, Kris. Thank you to you and the Growing Forward team for having me participate in this exciting conversation about red blotch. So my name is Marc Fuchs. I'm a professor of plant virology at Cornell University, stationed in Geneva, New York. My research and extension program is centered on viruses of vegetable and fruit crops. And red blotch came my way 12 years ago, believe it or not, in a serendipity way. But since then, my program has been involved in the development of accurate and reliable diagnostic tools. We have studied virus transmission after the insect vector was identified. We studied disease ecology in vineyard ecosystems in close collaboration with Monica Cooper in Napa and Kris as well. And yes, there are still plenty of questions that remain to be addressed for us to better understand this disease that doesn't behave like anything else I have encountered, and I think the industry has faced since the beginning of viticulture, actually. Thank you for having me.
All right. Thank you so much for being here. Yes, I definitely we're going to have questions for you as well about your experience researching this unique problem that we've been dealing with for 12 years. But first, let's go ahead and hear from Dr. James Stamp. James, would you like to introduce yourself and tell us a bit about how you interact with our red blotch problem these days?
Yeah, thank you, Kris, and thank you to all the my colleagues on this Zoom today, and thank you to the Growing Forward team for inviting me to be here. I got involved in evaluating nursery stock for planting back in 1999 when I left Novavine Grapevine Nursery, which I was a founder of. And I was asked by one of my clients at that point in time to go and take a look at some of the vines that were growing in the field nursery in the Central Valley. And they wanted me to go and take a look at the plants because they were particularly concerned about young vine decline. Various fungal pathogens associated with young vine decline. And if you recall, back in the the late 90s, we were very concerned about phylloxera. We were changing from using the St. George and XR rootstocks over to these French rootstocks that we really didn't have very much experience with. And at that time, the nurses were churning out all this new plant material, all these new rootstocks, and the plant material quality was very, very poor. So I went out to look at these plants. And as a matter of course, it just seemed to make a lot of sense, not only to look at the plants for fungal contamination and physical soundness, but also to test them for viruses. So right back in 1999, we tested a bunch of vines for viruses. And over a period from 1999 to 2010, we tested about 60 increase blocks of certified rootstock and scion. And we found that a quarter of all those increase blocks had either leaf roll 2 or leaf roll 3 or GVB virus. And that's how I became really interested in this project. So at this point in time, Stamp Associates is a consulting business. We work with clients, vineyard managers, wineries, grapevine growers throughout the United States. And they contact us to make sure that when they plant new grapevine plants, that those plants are of the highest quality possible, not only in terms of their virus status and their fungal pathogen status, but also in terms of the quality, the physical quality of the plant material. And there's definitely a correlation between physical quality and the pathogenic status of the plant materials. So that's my background. We have a lot of clients. We deliver thousands and thousands of plants every year. And red blotch, of course, is a very big problem, as is leaf roll 3. And again, thank you for including me today.
Yes, thank you for being here. I know I have clients that have worked with you and they're like, well, James is out there doing the testing for me, and there gives them a lot more confidence in making sure the stuff that they're getting is of the highest quality. So now I think we're moving on to the just kind of more open-ended conversation aspect of the webinar. And so I think I might ask Sarah a question first, and then we can just kind of see where the conversation goes. So I know from experience, mapping red blotch progression across the field is a huge time-consuming process. I mean, some people I've worked with have an absolute team of interns who are taking their time to do this vine to vine vine by vine across acres and acres, try to really understand what's going on. So are there tools that you're using in your research that might be really easily adapted for growers to use as well? How do you approach this problem of, look, I've got 5 acres to map. How do I get this done efficiently? And how do I make that information really, really relevant and create a product someone can use and then respond to?
Certainly, it's a challenge, and it takes a lot of work and time, and it's time consuming to do it right. I think one of the most important things is to get the symptom identification correct. As I said, it can be really tricky to identify the symptoms on this virus as compared to another virus like leaf roll 3, for example, that spreads like red fire throughout the canopy. So remote detection of this disease is really challenging compared to leaf roll 3. And so on the ground identification is still very important. So really well training your staff so that they can confidently and effectively and more quickly map a vine. Sometimes you do have to look at both sides of the canopy, and because symptom expression can vary from one side to the other. And so one of the tools that we developed in collaboration with Thule Technologies is Virus Vision, and that's a mobile AI app that scans a vine in 10 to 20 seconds and can give a confidence reading in one of 4 categories. That's red blotch, leaf roll, or other red leaf. And so that's a great scouting tool. And so getting familiar with your vineyard and the symptoms in your vineyard is key. But I will say that symptoms can develop throughout the growing season, and especially after veraison and then August through mid-October. So if you're mapping too early, you might be missing vines that are truly infected and will develop symptoms later. So if you're trying to minimize your mapping time, knowing when your peak symptom expression time is key.
Yeah, no, that's definitely been true. I've been out in vineyards and said, wait, that vine looked clean yesterday. And 48 hours later, oh gosh, what are those symptoms? Is that phosphorus deficiency? Is it potassium? Like what's going on here? Yeah.
So I'd like to ask Sarah a question. So
Yeah.
Sarah, when you're using the mobile app on your telephone, are you walking along the row and just pointing your phone at the vines, or are you using a drone, or how are you doing that?
We are in the field and pointing the phone at a vine. In fact, if I'll share my screen, I have a video example of that. Here is me in a leaf roll infected vineyard, and you see that infected vine in front of me. I'm scanning the app, and it will give me a reading.
And how well does it work on white varieties?
The app has not been trained on white varieties. Currently, it's only on red varieties. I did an excessive accuracy assessment this last fall. It does well on multiple different red varieties, whether that's Petit Verdot, Cabernet Franc, Merlot, Cabernet Sauvignon, of course, but not on whites. So data in, data out, we do not have it trained on white varieties currently. And then, of course, there are certain white varieties like Sauvignon Blanc where it just will not.
Okay, thank you.
So James, to answer your question, this is what it looks like from the perspective of the phone. It makes you a little dizzy at first, but then I'll press stop and it will give me a reading of confidence in Red Blotch.
And what if you were pointing the phone at vines that just look completely healthy?
Then it would say asymptomatic.
Okay. Thank you.
Yeah.
Yeah, no, that's a great point. Correct. Visual diagnostics are something, going to be important to understanding kind of what you're dealing with out there in the field. But I have a question for you, Marc. Other than that, the bizarreness of symptom expression and variability, what else has been really unique? I mean, you've been working with Red Blotch since we knew what to call it. What about this virus vector system has surprised you?
Well, Kris, I have been studying grapevine viruses for 35 plus years, believe it or not. And Red Blotch is not even close to anything else I was familiar with before we discovered it. It is very unique just thinking about the genetic makeup of it, the way it infects a vine. We don't know many viruses, or any actually, that would turn off the ripening genes around veraison to the extreme that Red Blotch does. Why does it do it the way it does? Why is it designed to do that? Are some of the questions we are trying to understand better. Why is it transmitted by a tree hopper? That is, in the history of plant virology, the second example where a tree hopper is known as a vector of a virus. And yes, that interaction between the virus and the tree hopper vector is very unique, because not only does the virus need to circulate without the whole body of the insect to reach a particular organ that is behind the eyeballs, if you want, located in the head of the insect, which are called the salivary glands. The virus has to enter the salivary glands in order to leave the body of the insect through a salivary canal to start a new infection. So in essence, that mechanism of interaction between the virus and the hopper vector is nothing novel. What is new with this system? It takes an extended time for the virus, after a hopper feeds on an infected vine. And what I mean by an infected vine, it can be a wine grape or a free living grape in Northern California or Southern Oregon. For example, Vitis californicas, or any hybrid of Vitis californicas with Vitis vinifera or any rootstock, are the only hosts of the virus that we know of. So if the hopper acquires the virus, it takes 10 days for the virus to circulate within the whole hopper to reach these critical salivary glands in order for transmission to occur. This is a very long time, and we don't quite understand why it takes so long. Another unique feature is once a hopper that carries the virus visits a healthy vine and starts a new infection, it takes, based on our observations, at least 2 growing seasons, if not more, for that vine to start displaying disease symptoms, suggesting that many, many vines can be infected in a vineyard prior to us visually identifying their infection status. That is also very unique. The other unique, so I keep on piling unique features of this pathosystem, as you can tell. Another unique feature is when it comes to the behavior of the tree hopper in vineyard ecosystems. And thanks to the collaboration with Monica and Sarah and everyone else in this team, we found out that the hopper spends more time feeding on anything else in a vineyard ecosystem but wine grapes. It feeds primarily on a number of weeds, shrubs, and trees, and by default, when usually during a dry year, all the vegetation around vineyards are dying off, they will jump into irrigated vineyards because that's the only green thing they can feed upon, or anything that grows green around ponds, creeks, whatever there's water and stuff is growing close to these water sources. And that's another unique feature of that system. And like the mealybugs and leaf roll, the tree hopper does not reside in vineyards. It's just an opportunistic visitor. It comes in and leaves and thrives outside of vineyards. So that's another unique dimension adding up to the uniqueness of red blotch disease.
Yeah, thank you. And how all of these facts finally unfold for us through research has been really, really fascinating to follow for these last few years. But that's a great segue to a question I have for James. So given all these challenges, these delays in virus inoculation and symptom expression, the fact that our nurseries are outside, right? We can't propagate anything in a vacuum. We have a great certification program, but our mother blocks from which all of our vineyard material is sourced are out there in the ecosystem. How do you approach sampling a vineyard mother block for red blotch?
Oh, good question. What we do is we look at the increase blocks every year. So we work with pretty much all the nurseries in California that have certified increase blocks, whether they be rootstock or sign increase blocks. And increase blocks are, I don't know if people know what an increase block is, but it could just be one row of 100 vines. It could be, 2 rows of 100 vines each. So increase blocks can be very, very large with rootstock materials and really quite small with sign materials. So what we do to give ourselves a better chance of being able to find viruses to go back to the same increase block every season. So we have a history since 2010, when the Protocol 2010 increase blocks were available, of going back to the same block year after year after year, and going back to the same rows of vines in those increase blocks season after season, and looking for symptoms of disease in those increase blocks every year at the right time of the year. And as you've mentioned, it's very important to look at the increase block vines at the right time of the year. And so what we do is at Stamp Associates is to go to all our nursery, I call them partners, all our nursery partners who we potentially will have orders with for the coming season, and walk all the increase blocks, walk both sides of the increase blocks of the sign materials to look for anything that looks strange. So as Sarah mentioned, looking at both sides is very important. It may also be very important in terms of her app, but just in terms of where the sunlight is shining on a vine. If it's shining behind you or shining towards you, it makes a line look incredibly different. A red vine can look very, very different depending on where the sun is shining on it. So again, we walk all the increase blocks toward the end of October, beginning of November, before the leaves fall off. And we determine that these increase blocks look good to sample. And so we go to every nursery in California that we think we might need their plant material from. We walk the increase blocks, we make notes. If we see anything that looks weird, we don't use that material, but we make that information available to the nursery. And several of the nurseries will go out there and retest those plant materials and see if there's a problem. And we certainly have many instances where materials that we found that look potentially symptomatic in the fall have actually proved to be symptomatic, and those vines have been removed by the nursery. So anyway, we visually evaluate blocks that look good. If we find contiguous rows of vines or continuous vines in a row that look healthy, then we come back and sample them. And we sample those materials when the leaves have fallen off, because it's easier to sample that way. So we sample the sign when the leaves have fallen off. And with the rootstock, I don't think Marc mentioned this, but it's well known that rootstock vines do not show symptoms of leaf roll or virus. And so with those particular plant materials, we also sample them when the leaves have fallen off, because it's really basically impossible to determine where a cane of a rootstock plant comes from while the canes are still, while the leaves are still on there. Because I'm not sure if the audience knows this, but rootstock vines are an increased block that have grown on a 12 by 12 foot spacing, and they're allowed to sprawl all over the place. So these canes might be 20 or 30 feet long. And to actually get to the center of a vine and be able to test the central material is very difficult to do when the leaves are attached. So what we do is, the only way we can be certain that we're testing, the only way we can feel comfortable that we're providing at least tested material for our clients, which can then get grafted, is to test every vine. So since 2011, 2012, when Red Blotch was first understood to be a problem and the PCR tests were available, I know Marc knows all about this and you guys all know about it. Since that time, I think it was the International Grapevine Virus Research meeting in Davis. I think it was maybe fall 2011 or maybe fall 2011. Since that time, we have been able to test every plant that would be a source of plant materials for propagation. And just to give you a rough idea, let's say you've got a Cabernet Sauvignon vine growing in an increased block. That one Cabernet Sauvignon vine might say have 400 usable buds. So if we can do thorough testing on one Cabernet Sauvignon block vine, and it may be that we take 4 or 5 samples from that one Cabernet Sauvignon vine, we will then theoretically know that the buds coming from that vine should be virus test negative if the parent material is virus test negative. Similarly with rootstock plant materials. And so we end up creating plant materials that have come from symptomless vines that then have tested negative for a whole range of viruses, and those are the materials that we then follow through the grafting process.
Okay. That sounds like a thorough process, and it definitely leads me, it makes me think about some challenging situations that I've dealt with, sitting down with panicked growers who, maybe had just placed an order, planted a vineyard, and said, Kris, we found red blotch. It's spreading. It's spreading like wildfire. It's going so fast. How can we stop this? And me being annoyingly scientific, always step back and say, okay, is it spreading or is it just showing up for the first time? So this question of how does red blotch enter the vineyard in the first place, I think challenges us all. And I was wondering if any of you, and whoever wants to go first, could help a grower discern between the difference of seeing red blotch in their vineyard that has always been clean and it's coming in from somewhere else, or that perhaps it came in on budwood or rootstock and is now just showing up. How could that pattern differ? How could they know?
I'd be happy to take a first stab.
Okay, great.
Excellent question, because it's a very critical one. And although we don't have a definite answer, at least I do not, I can share my personal observations and ongoing research to address that differential between, is it the planting material, the planting stocks that brought in the virus, versus is it coming through hopper or other vector-mediated transmission. So the one factor that is very critical to determine one versus the other is the age of the block that is of interest. If it's a young block, meaning up to the 5th leaf, it is virtually impossible to tell one or the other. The reason being that, based on my experience, if the scion is the source of the virus, the vines in the 1st or 2nd leaf should express disease symptoms. So that's an easy call. If early on you see disease symptoms, it is, and most of the vines, or vines that are aggregated in a certain area, meaning resulting from the close planting of bundles of 20 or 25 vines delivered by the nursery, that is indicative that the sign material was the source. Now, what is the confounding factor is if the rootstock is the source of red blotch on the grafted vine grape. Based on my observations, it might take 3, 4, or up to 5 years for the virus to move from the infected stock into the cyan, build up into the cyan, and the cyan develop symptoms. So very often in young vineyards, growers have the impression that overnight there has been an explosion of disease, very likely coming from the outside, while in fact they are dealing with the rootstock being the source of the problem. Now, in more mature vineyards, if assuming the planting stocks were absolutely clean, the rootstocks were clean, the cyans were clean, and there is some introduction of the virus, like on some of the maps, vineyard maps that Sarah generously shared with us, there is no doubt that the virus is coming from the outside, brought in through hoppers or maybe potentially other insect vectors carrying the virus in these vineyards.
Yeah. Yeah, Sarah, you've mapped dozens of vineyards now in Napa Valley. What sort of, how can you try to discern the two, or what sort of patterns do you tend to see?
Many of our study blocks are older established blocks, so we're confident that there is insect-mediated spread happening and secondary spread happening. Earlier on, I was involved in a mapping of vineyard that did have first-degree infections, where every 4 rows was infected material and every other 4 rows was infected material. So it was very clear when we made that map what was going on, because we saw strips of red and strips of green. Whereas in many of our study blocks, which are old established blocks, what we are seeing are hot spots of infection, either near a vineyard road or near a reservoir where there are those weeds that Marc referred to. And that maybe they're spreading from another neighboring infected vineyard into that block. In low infected blocks, we also see a random spread. So in blocks where you have less than 1% disease incidence, the block might be mostly clean. And when you do see red blotch, you see it here and maybe 40 feet over there and maybe 80 feet over there. And so that's a random spread we're seeing in low incidence blocks. When you get above 5 or 8% incidence, that's when we start to see those hot spots spreading neighbor to neighbor or within a certain 20-foot radius or so.
Yeah.
Hey, and Sarah, I've got a question for you. In terms of what your observations, are you convinced that the three-cornered alfalfa hopper is the vector that you're seeing spread from, given that we're assuming it's not dirty plant material?
Well, the caveat is my background is in GIS and remote sensing. So I really specialize in the spatial observations of the disease, and I'm not an insect biologist. So I'll defer to Marc for that and his research on that. We are trying to really hone in on that radius of, if a vine was previously symptomatic in year 1, where are the new infected vines and how far away are they? And so we're trying to hone in on that. So it's a challenging virus, as Marc referenced, because this is the hopper is a hopper, whereas leaf roll is spread by mealybug, which is more of a crawler. And so really those spatial patterns of spread you see are neighbor to neighbor, shoulder to shoulder, or directly across the vine. The new infections we're seeing are not exactly neighbor to neighbor. You do have a higher probability of that, but there is a bigger dispersal pattern happening. So that does point to something that can more hop and move around, but I'll defer insect questions to Marc and others.
Yeah, excellent question, James. Just to echo what Sarah is indicating, our latest experiments on behavior of the three-cornered alfalfa hopper indicates that, yes, that tree hopper is capable of very short distance movement, plant to plant, as well as very long distance movement. And when I mean long distance, we have direct evidence that they can fly more than a mile. In addition, in parallel, when we do try to assess their flight propensity and ability, we assess that they can fly up to 4 miles. So that's really long distance movement. And if you imagine one of these hoppers carrying a virus, yes, the neighbor that is 4 miles away can influence the incidence of red blotch in my own vineyard. But yes, if I start with a clean material, I agree with Sarah. My observations concur is that you have a peppery random distribution of a few vines. So what do we know about the three-cornered alfalfa hopper as a vector? We know it is a vector in the vineyard ecosystem. It is capable of acquiring the virus from an infected vine and is capable of transmitting it in the vineyard to a healthy vine. So we know it is a vector. We know it is not a very efficient vector, thankfully, although spread can be very rapid in some circumstances, but it is not an efficient vector. The transmission rate is very, very low based on what we know. Now, James, the additional question is the three-cornered alpha hopper the only vector? So far, it is the only vector known, but based on our history with grapevine viruses, it is highly likely that it is the sole vector of red blotch, right? There are likely other insects out there. I'm not aware of any other vector that has been characterized. There are many candidates that have been identified, and I think the final proof that these candidates are actually vectors is still lacking. However, this is an area of research that would be worth further investigating.
I got another question which interests me. The three-cornered alfalfa hopper is the vector. Is that originally associated only with alfalfa? I mean, why is it in California? Is it where's its center of origin? Is it basically hitching a ride with alfalfa? Growing in California. Is it just completely coincidental that alfalfa tree hoppers there, and we've got grapevines and we've got red blotch? These three things together.
Excellent questions, James. The short answer, I don't think we really know. What we know, historically speaking, it has been around and been recognized in California vineyards for a long time, but was a curiosity more than anything else because it is not known as a pest, right? So people knew it was there. Growers recognized them, farm advisors, IPM specialists, entomologists recognized the hopper. But who cared? Because it didn't do anything and it didn't stay in vineyards. Now suddenly that we know it's a vector of a nasty virus, people are paying more attention to it, right? So what we know, historically speaking, everything we know about the biology of the hopper was gained in the 60s, 70s, and 80s from peanut fields, alfalfa fields, and soybean fields in southern US states, where there the hopper is a pest. So we have a lot of background information of the biology of this insect, but obviously the question is, and we can anticipate the answer, does the hopper behave in alfalfa fields or peanuts or soybeans like it does in a vineyard ecosystem? The answer is likely absolutely not, right?
Yeah.
So, but yeah, we don't quite understand this virus insect host interaction when it comes to red blotch, although in terms of the virus, there are predictive computer models that have indicated, or at least suggested, that the virus likely originated many thousands years ago from another virus occurring exclusively in wild grapes in Northern California. So if these predictive models are correct, red blotch might have emerged in Vitis californica and Californica hybrids in Northern California many, many thousands of years ago. How did the hopper came into contact with the virus and the two together moved into wine grapes is still a big mystery.
Yeah, no, definitely. Let's pretend that we're going to research our way out of this problem for the industry, and that there is hope. So obviously still some questions about the virus vector interactions. What else do you guys feel like we really would just need to know? Like a couple of things that we need to figure out in order to help growers either avoid this into their vineyards, period, or be able to identify it early and get rid of it. What are some tools that we still need from the research community and then from outreach to get those tools out there to growers? James, I'll go for you first. What would make your job easier to get out there and say, okay, I know this doesn't have red blotch in it?
Well, I think everybody's job would be easier if we were considering, the possibility of using some of these genetic manipulation techniques to produce grapevine plants that were resistant to red blotch or Laferol 3. We know there's plenty of money, as you know yourself, plenty of money being spent on developing CRISPR methods for powdery mildew resistance or whatever it might be. And I think one of the questions that the consumers of wine should be asking, and I'm sure all the growers in California would like to know, is, okay, so we can go ahead and plant a new vineyard that tests negative for Laferol 3 and red blotch. Well, when are we going to be able to plant one of those vineyards and it not become contaminated with a dirty vineyard being right next door? Because that's the problem. I mean, we're talking about planting, maybe a 10-acre block, as you know, in Rutherford or Geyserville or Oakville, and we're putting in clean plant material or virus test negative plant material, which we think is virus test negative, but they're planting it right next door to vineyards that are completely contaminated. And so I think we should have a discussion in the industry somehow or other where we're talking about using and applying some of these modern techniques toward production of vines that have an engineered resistance to some of these viruses, as is the case in many other different crop species, potatoes, you name it, soybean. There are things out there, and of course, CRISPR and gene editing is a much more gentle tool than the old days of gene agrobacterium and what have you. So that's a quick answer from my perspective.
Yeah, host plant resistance would be an incredible tool, an incredible tool to have.
But in the meantime, if nothing else, it does make sense to at least test your plants for red blotch and Laferol 3. If I was a grower planting a vineyard in California and I had a limited budget, I'd want to make sure they don't have red blotch and Laferol 3. That is just common sense, and everybody should do that. And it's not very expensive to do it. It's doable. And it's just makes a lot of sense to do that. Yeah,
and by testing, you mean to the mother vines, right? Not after they've shown up. But
no, or you have, sometimes you can't test the mother vines because you didn't do that. In that case, you have to sample the finished product. So, for example, if you're looking at, say, dormant field finished bench grafts. So the whole concept really of producing clean plant material is that, okay, so you test the increased block vines, you test the sign and the rootstock, and then you graft them and callus them, and that usually takes place in some sort of clean facility. And then you have two options. One is to go into a plant pot, which means that you plant the vine maybe 3 or 4 months later, or you can go into a field. But then, you ask yourself, does it really make sense to go to all this trouble producing, identifying clean rootstock and clean sign materials, grafting them, and then putting them out into the open in a field in a location where there may be commercial production of raisin grapes or table grapes, where there are clearly vectors out there, mealybug vectors, for example, which might reintroduce mealybug into those so-called clean vines. And certainly the work that we've done over the years has shown that we can see virus, both red blotch and leaf roll 3, in those increased block row, in those nursery rows of vines where they're growing from that period from, say, May through to December before they get harvested. So there's two things you can do. If you're buying product that hasn't been derived from pre-tested plant materials, you can go and look at the plants in the nursery row in, say, September, October, and see what it looks like. If it looks good, that's good. And you could maybe do a screen there for red blotch and leaf roll 3. And then when the finished product has been harvested, you can go back and double check and retest that harvested, selected, finished product for red blotch and leaf roll 3 using statistically significant methods, and you'll have a good idea of whether there's red blotch or leaf roll 3 there. And we do that quite a lot, and we do find red blotch and leaf roll 3 in finished product using those sort of techniques.
I've seen that too. Getting back to the question about what else could really help propel us forward in solving this, Sarah, what do you see with mapping and GIS and advancements that could really help?
Yeah, it's certainly a challenge given there's no cure. So removing the inoculum is key and getting ahead of it. But the challenge is, how many vines do you need to remove to effectively get ahead of the spread? And so that's something we're actively working on with our mapping, because, you know, I'm married to a farmer and a grape grower, and some of his vines were planted by his grandfather. So every vine we have to remove just rips his heart out, and he would really rather not. And so if a vine is infected with leaf roll 3, we knew very much spatial roguing is effective. You remove the direct neighbors and you can be more effective in getting ahead of the disease. With red blotch, it's much more challenging to determine that radius of roguing that will be effective. So that's ongoing and active research, and I would like to see more of that, because as a member of the grape growing community and a grape growing family, we just can't research it fast enough to get answers into growers' hands. Yeah, because it is a slow developing disease. So we're trying to do it as fast as we can.
Yeah, for sure. Marc, do you have anything to add? What do you have up your sleeve? What's on your to-do list with Red Blotch?
Trying to do my best to help the industry as much as I can, and contributing to develop host resistance and even resistance to some of the insect vectors of viruses. I think is critical, but these are down the road applications. In the meantime, we have to keep in mind that there is no cure in a vineyard. Once a vine is infected with the red blotch, it will remain infected until it dies or it is removed. So as Sarah indicated, roguing is key, and the best strategy to apply to rogue red blotch disease vines is still pending. We still have to know what this means. And I'm pretty sure we're going to come up, depending on the history of the vineyard, the disease incidence, the rate of spread, into what I refer to as zonal roguing, meaning you're going very aggressive in some section of the vineyard, less aggressive or not at all in other sections of the vineyard. And to me, all ties in, and we talked about the extensive and the cleanliness and the quality of the planting material. And if I have to highlight one of the biggest accomplishments of red blotch, it might surprise you, but I will tell you that to me, the biggest accomplishment that red blotch has brought us is it tied together the different actors of the grape and wine industry. What I'm trying to say, never, like before the discovery of red blotch, have growers, vineyard managers talk so much with winemakers, with nurseries, with farm advisors, IPM specialists. This brought the community together. This is fantastic, thanks to red blotch. Now we are closer together, but we are still not pleased by certification. There is too much material that is still sold red blotch infected. And we should build upon these new opportunities to work together to change certification to a satisfactory level so that people have full confidence of what certified really means. If I'm certifying something, that damn thing should be clean. No doubt there. And I shouldn't need to pay extra money to verify that what is supposed to be clean is clean. So let's try to sit down, as we have done, and like James said, have an open conversation, and there is no reason why we shouldn't be able to do it, and fix these loopholes, because the cleanliness of the material remains very key. Because if the old blocks that have been established infected in the past 20 years or whatever are removed based on the low efficiency of transmission, we should be able to regionally reduce the incidence and start from a new slate and start cleaner.
Well, I'm going to add on to that from Marc because he's got some very good points there, as always. But, you have to look at grapevine propagation and consider what a sort of basic process it is. I mean, grapevine propagation, I think of grapevine propagation as something as like you throw the vines at the wall and you see what sticks, because that's how it works. What other business could you have where you have to work on the principle that roughly 100% of everything that you graft is not going to make it? So all the money that's spent on testing, spent on rootstock production, rootstock fertilization, science production, science fertilization, grafting, callousing. You graft 10,000 vines, you're only going to get 5,000 if you're lucky. And in some cases, you might get 2,500. And those 2,500 are the vines that just scrape through. And those 2,500 vines are going to be the worst. They're going to be the ones that survived, but they're the worst plant material. So what really needs to happen is that somebody needs to have the chutzpah, which is a nice way, rather than saying another word I could use, to actually spend some money on figuring out how to do grapevine propagation in a good way. And I know right now FPS has at last moved their increase blocks or their foundation blocks into the greenhouse, which is something that it's very clear that should have happened a long time ago. And this is the way, this is the future for grapevine propagation, where materials are grown in a clean environment. And the work that actually I did when I was with Agritope back in the 1995, when we were talking about greenhouse production of rootstock and sign cuttings, that is the future of really high quality grapevine plant materials, where you produce plant materials in a clean environment. You end up with absolutely fantastic graft unions. But we really need to spend some money on grapevine propagation, because we're working with a system that was never going to give us the quality product that we need right now.
I do have a lot of respect for the grapevine nursery folks. I've had many that have been as frustrated as the growers are on their challenges. We're almost out of time, unfortunately, but I definitely hear what you're saying, and it reminds me of something that one of my mentors said, Dr. Deborah Galino, who we unfortunately lost not too long ago. Start clean, stay clean. That's what she taught us all as students, and that's what, as an industry, we're trying to do. So I'm hoping that with improved nursery practices, more research on understanding some of these unique challenges with red blotch, and some tools with how to, when it does exist, effectively rogue it from our vineyards, can hopefully get us where we want to be. And I think we're out of time, so I wanted to thank you all so much on about this conversation. I'm sure we could all keep going about it for hours, but thank you so much, and thank you to everyone who's joining us today. And I wish you the best of luck in growing grapes in 2024.
Yeah, thank you.
All right, thanks, guys.
Good luck to everybody.